Hello everyone, my name is Zhang Chuan. I'm a senior student majoring in digital media technology at the Tianjin University of Science and Technology. When I was 14, I watched my first anime, Sword Art Online. It's about a guy who gets trapped in a VR MMORPG game called SAO. And all the adventures it goes through, I was so hooked by it that I watched it for several times. And it sparked my interest in VR and game development. That's actually one of the reasons I chose to study digital media technology and why I'm here today. Because of COVID-19, I couldn't really get involved in my university soccer team in my first 2 years, even though I love playing soccer. Instead, I started to running alone at night. It gave me a lot of time to think, reflect, and just be with myself. Most of my social life during those years was focused on my lab, where I got to work a group of motivated and like-minded people. When I was a freshman, my senior gave me a lot of help, especially when I was looking for internship. One senior who worked at Lily's Games helped me to polish my resume and gave me great advice on which internship to apply for. I'm really grateful for her guidance. Now, as a senior myself, I enjoy helping out the younger students, like sharing my experiences with them, and I hope it could help them their journey a little easier, just like my senior did it for me. When I first started the university, I hadn't taken any game development courses yet, but our school held a game jam, and a few other gaming enthusiasts and I decided to make our first game using RPG Maker. Looking back now, that game was pretty rough in many ways, but it was a great opportunity for us to come together as a small team, get to know each other, and start learning about game development for us. That experience meant a lot. After that, I learned C language, taught myself the EasyX graphic library in C++, and made my second game, Liu Ha Qiang, with Tashkun. This game was a part of my lab assessment, and it was helped me to join the lab, which had such a big impact on my university life. During the winter break of my freshman year, I participated in the Roblox developer training camp, which laid the foundation for me to learn other game engines like Unity. At my lab instructor's suggestion, I also started experimenting with AR and taught myself Unity, because our school's university courses didn't start until my third years. As a result, I created a local two-player airplane battle game in Unity, inspired by a minigame in Pummel Party, as a project to show what I had learned. In the second semester of my freshman year, my team and I started working on our first VR game, Botany Ancestor. We also participated in the Unity Game Jam for the first time. Well, we only won the Excellent Award. That project gave me a huge boost of confidence, and for a long time, it was a source of pride for me. I will talk more about Botany Ancestor later. After that, under the guidance of our lab instructor, we tried out to some visual human projects. At first, we want to use optical motion capture and build scenes in Unreal Engine 5, using Icon 9 and FaceLink to drive the motions of visual humans. But due to our limited technical skills and lack of proper hardware, we ended up with using Maya and Blender, where our animation team manually keyed the character animations. In my sophomore years, I became somewhat well-known at school, mainly because of my VR project. Professors and students from food science department started to reach out to me for VR projects. This let me try out some VR applications in industries. One of my projects was a visual fermental lab, where users could experience the process of making white wine VR. I also try to integrate an OpenAI driving digital virtual human to explain the process to users. During the summer after my sophomore years, I got an internship offer from Beijing Joy Castle Technical Company. This internship was a great opportunity for me. Not only did I improve my technical skills, but I also broadened my horizon and grew a lot as a person. My teacher even mentioned that I'm still much more measured and composed when I came back. Additionally, I learned how to use Git, which has been really helpful in my later projects. Before learning Git, our team used to send project files back and forth via USB drivers or zipped folders. But now, with Git, everything is so much more efficient. In my junior year, the course's work was heavier, but I also made a lot of progresses. Two projects I'm especially proud of are Pages A and Angry Bird AR, both of which I composed as a part of course's design. I will talk more about them in details in my portfolio later. Now let me talk about Pages A. The idea for this game actually came from a game I loved playing when I was younger called Gun Mayhem. It brought back a lot of great memories for me, but the problem with the local multiplayer games back then was that when 4 players played on the same computer, there were just not enough keys in the keyboards. So I decided to create a local multiplayer game, Pages A, where players can battle each other. Honestly, even though I had taken computer networking courses and I had learned about 5 layers architecture and TCP/UDP protocols, and even scores well in the exam, I realized that just theoretical knowledge was not enough to help me in real development. To learn how to make a multiplayer game, I bought a few Unity books and started to learn by following the examples in the books. The books used Photon University networking, which provided free servers for players to use, and the SDK was pretty easy to work with. But the problem was that the servers were in Hong Kong, not in mainland China, which causes huge network latency issues for a multiplayer game. So I had to scrap the idea and find another solution. After considering the time and cost, I decided to switch the local network multiplayer setup, which would avoid the need for setting up a server and dealing with high costs. I found a multiplayer framework called Network Code Plus on the Unity Asset Store, and after running the sample demo, I confirmed that it was a feasible solution. However, the document wasn't very helpful, so I ended up driving into the source code of the demo and to learn how to use it properly. In terms of game design, our initial plan was to create 9 different weapons and 3 different environments. But based on past project experiences, we realized that often things don't go as planned. So sometimes we don't even finish everything. So we decided to prioritize to getting the game functional and then add more content later. We broke the project into modules, with the first module covering about half of the total work, but already being a complete game on its own. The second and the third modules were just expansions of the first. In the end, it was the right choice because when we finished the first module, we were already close to the deadline. It wasn't exactly what we had envisioned, but it was still a complete game. Now, let me introduce Pages 8. It's a local multiplayer battle game where the last player standing wins. In addition to the basic weapons, the bubble gun, we designed 3 more weapons: the thunder staff, the holy great axe, the stargaze pie. These weapons can be found in randomly spawned treasure chests in the game. Each weapon runs out of memos after certain numbers of regular attacks, or after using a special attack. The thunder staff regular attacks release multiple ball-shaped lightning bolts that stay in sync for a while, damaging any enemies they hit. Its special attacks lock on to nearby enemies and strike them with a powerful lightning bolt. The Holy Great Axe regularly attacks through a massive axe forward, and its spell attack summons multiple spinning rings around the player and can both attack enemies and destroy enemies' projectiles. The Stargaze Pet regular attack shoots 3 fish forward, and its special attack summons a giant fish head that shoots a laser at enemy. And when the player dies, they turn into a ghost and can continue to follow around in scenes to watch the rest of the match. Now let me talk about another project I did called Angry Bird AR. This was one of my projects in my augmented reality class. The original text from teacher was pretty simple, just to scan an image or book with specific items and show a static AR effect, like pictures, videos, or 3D models. To be honest, I thought this test was kind of boring, so I want to make something with more interaction. At first, I thought about using a depth scanning camera on my iPad Pro to create a game where visual objects could interact with a real-world object through the physical collection. But then I realized that to build an app that could run on iOS, I need a Mac device, so I had to change my plan. That's when I decided to create Angry Bird AR. In the process, I used plugin detection to let users build PG fort in any enemy space. And then I attached a slingshot to an AR camera to shoot different birds. But there was one problem. When you scan with AR, the camera's movement was unstable, and that would cause the PG's fort to fall due to the visual earthquakes, not the birds hitting them. To fix this, I turned off the gravity for the PG fort until the birds hit them. And only then did I activate the gravity. This way, the fort won't collapse because of the camera's instability. Now, let me explain a bit more about the game itself. In Angry Bird AR, players can scan different patterns on the booklet that I designed and create myself in InDesign. This booklet unlocks different birds and levels. The images in the booklet are from the Angry Bird movie. The idea is that players use different birds to knock down the PG's fort and score points. When they reach a certain score, they complete the level and move on to the next one. Now, let me tell you about Botany Ancestor. This is my second Unity project that also my first VR game. Even though it has its fair share of imperfection, it's a game that means a lot to me, so I really want to share it with you. Botany Ancestor is a puzzle-solving, exploration-based game where players solve different puzzles like one-stroke drawing, rotated discs, and water pipe connections to progress. In this project, I was mainly responsible for writing the code, but the level I uploaded to the website was actually one that I didn't myself, called number kioski. I think it's the most challenging level in the game, and it's actually some quite a few people, including myself. So it's a really important project for me because it was my first attempt to develop in VR, and it really helped me to grow both terms of technical skills and problem solving. Now let me talk about what I'm working on right now. During my long experiences with VR development, I realized that motion sickness is a major problem for many VR games. Since motion sickness happens when there is a mismatch between the visual movement and the physical movement of your body, I thought, why not make them completely match? That's when I started to believe that mixed reality has huge potential. The project I'm working on right now is called the Mixed Reality Multiplayer Combat System, based on point cloud reconstruction. It's also my graduation project. My idea is to use the scanning features on the Quest 3 to capture real-world scenes and generate point clouds of those scenes. Then I will process those point clouds using PointNet and deep learning. I could either preload visual projects like walls, floors, tables, and match them to the real-world scene. Or I could use generative AI to create stylized 3D scenes that match the size and layout of the real world. This would blend the visual and the real world together seamlessly. The goal is that players can move around in the visual place without worrying about bumping into the real-world object, which will help align the movement of their body with what they see in the VR. Of course, this project is still development, and I'm currently starting from scratch in learning about deep learning, point clouds, and related technologies. I'm really excited because I plan to show the results of the project in my graduation studies.